Hello everyone. In this tutorial we will be creating a game in HTML using the HTML canvas. We're going to be using a physics library called Matter.JS. This is simply to get you started. This is not actually creating a game. This is to get you started on the steps of creating a game. I highly recommend that you check out Matter.js documentation because that's really the core of the engine, the physics, and what you can do with it. There's a lot you can do with Matter.js, and we're simply going to really just build an input system and a sprite system so you can actually visualize stuff. So first of all, I just got this bare HTML file. I made a canvas, named it ID, gave it a width of 600, height of 300, and just to make that bigger so you can see. Then I also created a Java.js folder which will contain all the JavaScript files. I also have a file called images. This contains all the images that I'm going to be using for this tutorial. I just found this off of Google and just quickly made these really bad pixel art stuff images that we will use. So let's get started. And for JavaScript, we will let's create a base.js. I like to wrap everything around in namespaces. So, for example, this function, right? I'm creating a function, right? And then this function is created, and then I'm executing that function, right? So base will be equal to whatever the execution of the function leads to, which will be an object, right here. And within this object, we will basically give it public functions and variables that we can mess around with. So for example, canvas document.getElement by ID. We named it. I think the ID was game. Yes. And then we also want to get the context, the 2D context, context of the canvas, 2D, right? There you go. So you can see the entire thing. And then we also want to create just a function for vector2 that contain x and y. There you go. And then let's just reference this so we can use it outside of the scope. Vector2. So first of all, we need to create a class called transform because we need some way of keeping track of an object's position, the transform will contain the position. So vector2 will just default to 0, and a rotation, which we will also default to 0. This rotation will be in radians, so that's pi stuff. Mat.pi is 180 degrees, 0 is 0 degrees. Mat pi divided by 2 is 90 degrees, and so on. So we have this. We also want to, of course, use that outside, which is great. Thing is, we're going to create a class called entity, and it will contain a constructor and with the comp. I'll explain what this comp is. Basically, this comp is you will create a class. Let's say that you want to be an entity, in this case sprite, and we want it to extend from entity, right? When we call the constructor, we want to say, hey, the component that this is sprite. It's the exact same, right? It's exactly what it is, sprite. You cannot say this. Do not say this. Say sprite. So it knows you're talking about the type sprite. And because you want to create a static variable that's called all in all caps and make it a list. This will ensure that when you pass this sprite in, this comp is going to equal to that sprite, and then we're going to say sprite.comp dot static all dot push this component into that list. So now the list will contain every single entity of sprite, which is exactly what we want. Let's go ahead and split it up. Let's actually put that in a render.js. So render equals function, and we can put that here, return, just so we're organized. If your project is getting bigger and bigger and bigger, you definitely want to organize your stuff. Otherwise, you're just gonna get out of control. Of course, the components to the sprite, we also want an image, right? So this image, and we're gonna give it a transform, a default transform, new base transform, capital T, right? So it's gonna be initialized to everything 0, and then we can of course tweak it if you want. So this is only going to contain the data. An entity will only contain the data. It will not contain any functionality. That's not what the point of an entity is. The functionality is going to be contained within a system. Let's actually get this properly in. There you go. A system. So entities and system, they pair together. If you create an entity, you're probably going to create a system for it. Constructor. We also want to know on what component are we actually going to be working with, right? What component are we going to be working with is basically what that asks. And every single entity must have a static variable called all that is a list. It must, because then what this will do is this is a function called run. We should be able to run the system called the run function. That's it. We're done with it. It does everything on its own, because it will have a reference to every single instance of that component, of that entity. So for example, the entity of every single in component.all, right? And then we want to call a function and pass it in the entity, this action. Now this action is not going to be defined here. It's going to be defined in anything that extends it, inherits from it, which in our case, sprite system will do that. So class sprite system will extend base.system, and we want to of course pass in what component are we working with, sprite, and we want to give it action. And since we know what entity is going to pass, it's going to pass a sprite, we can call it accordingly. And basically, what we're going to do is work with this sprite. So the base.context is stored here. What we want to do is translate it to the transform.position. We can make for more readability. Since sprite has a transform, we know that we can access its position, and then that translate it, and then we can also rotate it as we like. So sprite dot it's t dot rotation, right? And then we can do base dot ctx dot draw image sprite dot image 0 0, and then 0 0 because we already picked the position here. So we just want to give the origin of wherever we translated this. We also want to undo this. We wanna rewind what we did and set it back to normal after that. So we just negative everything. But also we need something extra. We need the scale. The scale of the sprite. By default, we can make it 50, right? 50 by 50, and this will basically draw it according to the scale. So that's good. Okay. That's cool. Let's create a setup.js. This will basically be our setup. Let's create a function so we don't have any global variables, so we don't get confused. Make a const sprite system, We'll call it render.sprite system, right? And all we have to do for sprite system, we don't have to tell it anything. We just create it with new and we run it, right? So we want to actually run it every single frame. So let's create a render function, and do sprite system dot run. It'll run, and then we want to, of course, request for it to be rendered over and over and over and over again. Okay. So now this will keep drawing the sprites. So that's good. We can test this by actually creating a sprite. So I'll actually do it a global just for now, just to show. But we can create a player, and actually we're going to create link. Let's get the image first. Render.get image of link.png, and we don't actually have this function in here. We'll create it here. Get image. This will basically give us a path and will give you an image of that from that path. Right? We'll do image.source equals to, now because every because every image is stored within the images folder, I'm just gonna prefix it with this so I don't have to keep typing it over and over and over again, and then we can just add the path with it and then return image. Then of course make it use for outside, and now we can use it here, right? So we loaded the link, the link image, and then we can say player is equal to new render.sprite link, give that position, and if you actually go back here, right, reload it, we'll see nothing. First of all, we'll see nothing because we added nothing to the index, and we want to add all of them, all the scripts that we created. So first base goes here, then goes render, and then goes setup. In that order, we had to do it in that order because scripts, these other things are dependent on other, like a render is dependent on base, and setup is dependent on render and base. So there you go, we have it done there. We want to make sure that this is accurate, that it is drawing the image where the position is. So since I made player global, we can do transform.position.x, and we can increase that by like 100, and voila, it teleported. It went right to 100 units. Now, why is there two links? That's because we are not clearing the canvas. So it's just going to draw over the canvas over and over again. So we want to clear it. So we can create another helper function here called clear screen, and this will just clear the screen. So we can do base.ctx.clearRect 0 0 from the 0 position to canvas to however big the canvas is, canvas width and canvas height, and that will clear the screen. If we actually do it here, so render.clear screen. Now if you actually do that here, player equals player dot transform dot position add one, voila, see that? It teleported. It did not duplicate this time. That's because we're clearing it. So we know the render system works, so we know it's accurate to the transform. We actually can even try and do player.transform.rotation and add, let's rotate it by 90 degrees. So that's, remember this is in radians, so for 90 degrees is math divided by 2, and it'll do that. So you'll notice that it actually rotates from the top left of the image, top left. If you want it to be the center, we should actually add this. We should add an offset, and we'll make the offset 0 by default. But if you want it to be the center of the object, if you want the rotation pivot to be the center of the object, you want to create the offset to be half of the scale negative. So this will be negative 25, negative 25, right? Because that's half of 50 and the negative of it. And over here we have to change it. We have to say sprite.offset.x and sprite.offset.y. Okay. And now we can actually do it here. Watch. Reload. Player.transform.rotation. Is equal to math.py divided by 2. It's rotated. Now it's rotated out off the screen because top left was the pivot point for its rotation. Because if you move the x position to 100, we will be able to see it. And if you want it to be the center, we can do player.offset.x is equal to negative 25, and player.offset.y is equal to negative 25. Now it's the center. Now if you do player.transform.position.y plus like 200 or 100 to go below, we can rotate it now. Player.rotation or player.transform.rotation. We want to add a math.py, which will do 180 and then 90 degrees. Math.py. This will put it back into the stand form. See how it rotated from the center there? That's supposed to be the offset. So that's how you can get it to work over the center of the object. Okay. Next, we're gonna have to do. We're actually gonna have to do input system. We want to create inputs. We want to be able to control this. Controlling the position would be fantastic. That would be a fantastic start. So let's create an input.js script. Const input equals function. Right. So we'll create helper functions. Add event listener, event name, and then callback. And we also, of course, want to create a remove event listener, event name, and callback. And to do this, we basically want to do window dot add event listener, event name. We're basically making a wrapper for this function. That's not supposed to be add. That's supposed to be remove event listener, right? Yes. And then return. There you go. Add event, remove event, just like that. This works. You can experiment with like, oh, I want to add it to the document instead of the window. The window works for me. Always choose the window. It works for me, so it'll work for you. So that's good. And then in the setup, we want to actually add in the functionality for the input. So this will be input stuff, and this is render stuff. So for the input, we'll do input dot add event listener key down when a key is pressed, and we actually want to console.log e.key code, and then we actually want to add the input system into our HTML. Remember to add it to your HTML script. So now if you press W, look at 87, that's the key code for W, and this is useful information because now we can make a switch statement. We can say e.keycode case 87. That means up. And then we can say case when we press D, it's 68. So 68 means right break. Case, let's go down. 83, which is going in clockwise direction. Down, which is great. And then we can do case A, which is 65. And this is left. This is actually left. I got mixed up in the directions. Oh no, this is right, this is left. Yeah, that's fine. Right, so we can add functionality here. Thing is, we want to create input, but we don't want to tell it exactly what it is. For example, input. Oh yeah, it's got an input. That's cool. That's cool and all. But are we going up? Nope. Are we going right? Nope. Are we going down? Nope. Are we going left? Nope. Nope for all. We set these different parameters to true or false, and we get different inputs. So this will automatically make input.up equal to true. This will make input.right equal to true. This will make input.down equal to true, and this will make input.left equal to true. Because now we will add in a function to check for our inputs. We will add it, and that will be every single time. Every single time we want to update the physics, the engine, basically. So we want to create an interval. Set interval, and let's create it every so 60 frames per second. Consist 60 frames per second. And we want to just say, okay. If input.up is true, do this. What will it do? Well, it will take the player dot transform dot precision. You can actually do const p equal to player dot transform dot precision. It will make the precision dot x plus dot y minus, because upward is minus. We can also give it a speed of 1, I guess. Speed, there you go. And we say if input dot rate p dot x plus speed, if input dot down p dot y plus speed, and then if input dot left p dot x minus speed. Let's check this out. See how this does. Oh, look, that is working. Problem is, if you press right, it'll keep going right forever. If you press down, it'll keep going down forever, because we're not turning it off. We're not turning the input off. And a way to do that is, the best way to do that is through get key up. When we get key up, we can set all these to false instead. If the get key is up, set it to false, set it to false, set it to false. Right? So now when we actually let go of the key, when we're holding right, it'll set it to true. But when we let go of the key, it'll set it to false. That's exactly what we want, and we don't need to console.log this anymore. So this is great. The problem is now, what about physics? Well, we want to add this Matter.JS. So you can just search it up, right? Click this link, go to this link, and then go to source code. No, do not go to source code, sorry. Go to latest build, and it will send you to here. This is one file that contains the entire Matter.js library. Click raw, and then Control A to select everything, and then Control C to copy, or you can just right click and copy, same thing, and then go over here, create a new file, a new JavaScript file called Matter.js, and then Control V or right click and paste, bam, and then save it. Don't worry, it's a huge file, yes, but this is the entire Matter.js library, the entirety of it. Don't look at it. You don't have to look at it. It is quite scary to not look at it. But we will reference this before everything, right? Because our other stuff will be needed for Matter.js. And now we want to incorporate our sprite system and transfer system and stuff with our physics system. So let's create a world.js const world equals function, right? Return. Basically, we want to make it easy to be contained in one world and to do stuff within that single world. Okay, so first of all, we want to create an engine. You can create multiple engines, right? But we just want to create one engine. All right, that'll be our BR's world engine, right? So anyway, engine equal to Matter. That is the namespace for the Matter.js library dot engine dot create, and then we need access to the world that's contained in engine dot world, right? And we can say, hey, want to mess around with this? Go ahead. Want to mess around with this? Go ahead, right? Now we want to say, okay, there's actually no way to run the engine. Right now it's off. By default it's off, so we want to run it. So let's create a helper function to run the engine. Now the thing is, we can use what is called matter.engine.run. We can use this, but we're not gonna because it doesn't give us as much freedom. We're gonna do matter.engine.update instead. And ask for a delta. We'll name this timestamp. This timestamp is in milliseconds. So this basically says we want to update this engine by this many milliseconds. So that means by this many milliseconds, go that much forward in time in the simulation. That would happen in a snap, but we actually want to wait real life seconds, right? We want to update 60 frames per second, right? And we want to wait 60 frames per second, consecutive 60 frames. It should update consecutively, right? And so we want to set an interval for that. So we want to say interval update this at this time step in that interval. All right. Run engine. So that'll do that for us. Run this only once. If you run it more than once, it will start updating it twice as fast because it'll update it, whatever. We'll actually make a safety. We'll make a precaution for that later. But function dot. We'll first have to create a rectangle collider. Not create. In this case, the call it bodies. So we're gonna stick with that to be consistent. We're gonna give it an X position, Y position, a width, and a height, and then options, which is optional. You don't have to give it options. That's optional. And so rect matter dot body dot create. We want to create a rectangle. This is actually in bodies dot rectangle. You have the X position, the Y position, the width, the height, and the options that are optional, of course. The thing is now a rect is it's just a rectangular body, but it's completely empty. I mean, as in, it's not in any world, and we want to add it to our world. What world do we want to add it to? Well, the world that we have right here. So we can do matter.world.add body to what world? Our world, the rect. And then we can return the rect. This is why we create the helper function, because it adds the body for us automatically, and then also returns it. So we want to reference that. Okay, that's good. So now, let's try and test this. So what we can do is, of course, go to setup, we're gonna create another function. We're gonna create physics update, right? We're gonna create a body. We want to create a collider. So let's create a collider. Okay, a rectangle collider. Body. A rectangle body. World dot create rectangle dot body 0 0 50 50 and no options. Okay, that creates a body. The thing is, the body actually has a position variable that points to x, and an object that contains position x and position y. And this transform has the same thing. The thing is, we can now create for example, this right here. We can make player.transform.position point to the body's position. Right? And that's it. We'll only have to make it once, and it will automatically update for us. It'll automatically update the transform for us. So if you actually go ahead and also run it first, world.run engine, and see what happens. Okay, so world is not defined. Did we not add it into this? We did not. Script source equal js.world. But now, yeah, so it just falls because it's gravity. Let's get rid of, for now, let's get rid of the gravity. Set up world.gravity, world.world. We want to access the world, right? This is the namespace and this is the actual world. Gravity.y equals to 0, and now it should just stay there. And we can move around the transform. We do not want to do that. We do not want to directly move the transform. That is not good practice. You actually want to use, if you want to do that, you want to use Matter.body.setPosition. Use this function to do that. Anyway, we want to actually use forces, so it reacts with the actual physics world. Well, we actually want to create events first. We can create function dot add event listener, event name, and then callback. So this is for matter.events.on on what engine? On our engine, the event name, and then the callback, right? And then we also want to be able to remove event listeners, name, callback, and that's through matter.events.off engine, event name, and then callback, right? And we want to add event listener, remove event listener, remove event listener. There you go. There you have it. This is really useful because now we can go and set up and say, instead of doing this every interval, we want to do it world.add event listener before update. That's a function. That's an event, an engine. So before update, this will trigger this function right here before update. It doesn't matter at what rate the physics engine is being updated. It will run right before it calls the update, which is exactly what we want. And of course, this will actually work the same right now. Right, moving super fast. It's not reacting physically though. It won't do it properly. Luckily, there's in body it's called body.force, right? And this value is set to 0 for x and y after an update. And if you make it greater than 0 or lower than 0, it'll add the force to the body accordingly in the next update. So over here we can actually do player.body equal body, so we can reference it later. And over here we want to do this. We want to point to player.body.force instead. I go to it. Now, yeah, it's going to go really fast. Make the force like 0.001, the speed 0.001, and that's much slower pace. But now it's actually reacting to like physics. Now, if you wanted to stop instantly, right? Because right now it has some drag. You can add some options here for the body. You can say friction air 1. It'll stop instantly. See, it stops instantly. In that case, increase the speed. See, so now it stops instantly after it applies that force. It stops instantly, and you can move around as long as the the speed is great enough that it can actually move enough before it stops. Okay. So before update, there's also obviously after update. So after it's updated, and we will actually be using that. Why? Because because you know how we said, the transfer dot position. Yeah, that's being set to whatever it is. Problem is, the rotation isn't, and the rotation is value based. So we have to set that after the update. So right after it updates, our new player transform.rotation is equal to player.body.angle. That's the angle that's in radians. This will also be in radians for that reason. So now we're actually having correct rotation. Which is great. So that's good. And we can Control Z. Yep, it's working normally. Now let's try and create a static just a wall, just a wall, right? So we don't want it to interact with the player or anything. So we can do well, this wall is going to be world.create rectangular body. Create it at 100, 100, 50, 50 as well. And in the option, we actually want to make it static. It's the wall. It's not moving. We're never going to move it. Alright? And then this will automatically add it to the world, but there's no sprite to it, so there's no visual representation of this object which we want. So to do that, we can simply do const a sprite, and we can do new render.sprite, the capital S. We're gonna give it an image. We're gonna actually give it an image of get image right here. It says in images tiles, so tile slash stone.png. Okay, and then sprite.transform.fusion is equal to all that position, and we know it's static. We don't have to keep track of its rotation. Otherwise, you would have to add an after update as well. We can actually create a helper function, which would be great. Every time you create a helper function, you should probably do it, because then you don't reuse code. You don't keep writing the same code over and over again, and you might make mistakes when you keep rewriting it. So we say create sprite for this. We can give it a position, we can give it a width and height, and we can give it options as normal. The sprite, well, actually, we can give it a image and a body, right? Image path. There you go, and a body. Yes, exactly like that. You know what I can do? Do sprite. Exactly. Then we can do sprite.transform. Well, sprite.transform. We know we will have it. Dot position equal to body dot position, and then we can add event listener saying after update. We wanna do sprite.transform.rotation equal to body.angle. There you have it. Now it'll actually update after as well, which is great. So we can create a sprite here. There you go. And now we can can actually use that for the wall. Instead of creating like this jumble mumble, it might actually be wrong. Be pretty long. We actually want to return the spread as well. And sprite dot body equals body, just for other reference. Sprite here, so we can just do world dot create sprite. So we feed it in the sprite, which is this, and then we also feed it in the body, which is this. You can create even more helper functions if you wish, but this will take in a sprite and taking a body and sync them together. That's what it'll do. And this should create a wall. So we reload. Missing. Oh, where am I missing? A comma. Okay, here you go. So get image is not defined. Oh, that's right. That's right. It's render dot get image. And there you go. It's right there at 100 to 100. It collides and everything. Now you can't actually see it, but I suspect that the rectangular collider on this object might be rotating, because if I hit it with a corner, it might rotate, but it might not be, because the air friction is set to 1, so it might not be here. But if your air friction is not set to 1, then it might be rotating without you knowing it. So I highly recommend that you actually read the Matter.JS documentation. Read it, please. You will get so many ideas, and you will learn the potential of what you can do with this physics engine. You can create sensors, and then you can create triggers and stuff, and you can create a bunch of stuff with this. Like, there's some cool demos it even has, right? That you can mess around with and stuff and see what you can create. It's a great tool, and I highly recommend you go to the documentation and read it. Once you want to read a really bodies, and well, start with those two, and then just go there from on out to other stuff. If you want to know if a body collided with something else, you can use this. This is an optional parameter. You don't have to have it. So this checks if body A collides with body B. If it does, it returns an object, and you can console that log what it returns to see all the options available and everything. There's a lot you can do with Matter.js. So it's just your starting point. I mean, you can create another frame, a sprite system, because the world actually contains a list of every single body in bodies right here. It contains a list of every single body within that world, and you can just for loop over it. Just go through it and create a wireframe of the colliders. That is possible. I've done it before. That of course you can do to challenge yourself and create whatever you want in this game, in this little tutorial that I've set up to help you get started actually putting things together and making things work. So I hope you enjoyed this tutorial, and that'll be all for now.